In last class we have seen logical database design, means we converted company database here diagram into relational database tables. Today we will see physical database design with Oracle. The aim of physical database design is to decide how the logical database design will be implemented. In our course we are using relational database. For relational database, this physical design involves defining table structures, defining data types for fields, and defining constraints. In previous classes, we already discussed DDL and DML commands, so we know how to define the tables and data types, but we need to know how these constraints will be implemented in Oracle. Before going to design this company database schema, let us see first relational database constraints in Oracle. Here we have Not Null Constraint, Unique Constraint, Check Constraint, Primary Key Constraint, and Foreign Key Constraint. Let us see all of them, how we can implement this in Oracle. Then we will move to the company database schema creation. Constraints. Oracle uses constraint to define integrity constraints. Constraint means it is a rule that restricts the values in database. Oracle database lets you create the following constraints: not null, unique, check constraint, primary key constraint, and foreign key constraint. We can create all those constraints at column level as well as table level. Column level constraints refer to a single column in the table, whereas table level constraints refer to one or more columns in the table. In column level constraint, they will not specify column name because they will be specified for only one column. Table level constraints specify the names of the columns to which they can apply. Not null constraint must be declared column level, means we cannot create this not null constraint in table level. Remaining all other constraints can be declared as either column level or table level. Let's see first one, not null constraint. Not null constraint is a restriction placed on column in relational database table. Not null constraint prohibits a database value from being null, means it enforces the condition that in that column every row of data must contain a value. It cannot be left blank during insertion or update operations. If column is left blank, then not null constraint will raise error. Syntax for not null constraint is create table, table name. After this column definition, you need to specify this not null constraint. This syntax is for while creating the table. Even we can add constraint already existing table, means we have some column name. We can modify that column by adding this constraint. In that case, syntax would be alter table, table name, modify, you need to specify column name, then constraint. This is used if you want to apply constraint for the existing table. And you can even add constraint like this, means if you want to add new column for existing table, while adding that new column you can specify this not null constraint. Alter table, table name, add column name and its definition, then this not null constraint. Let us see how this not null constraint will be enforced on database by using Oracle. Let us create simple table student with 3 columns. Create table student, student ID character of 10 which is not null, name varchar of 30, GPA, floating point number. Table is created. Let us see the description of that student table. See here, the student ID column is having constraint not null, means in the student ID you cannot enter the null values or you cannot left it blank. Let us check now. Insert into student values. This is the student ID and name is Raghu and GPA is 8.9. One row is created. If you check the table, one row is inserted. Let us try to enter another row without specifying value for student ID. Here I am giving only values for name and GPA. So we need to use this syntax, insert into student. For the columns name and GPA, values are Lakshman and GPA 8.2. See here, Oracle raising error, cannot insert null into the student column SID. So this not null constraint enforcing that you cannot leave this SID column blank. Let us try to enter null value into this SID column. Here also it is raising error, but this not null constraint will allow duplicate values, means same value can be there for that column SID in two tuples. See here, insert into student values B171 256 and name is Suman and GPA is 8.9. This ID we entered for another student Raghu, but this duplicate value is accepted here. Let us check the data within the table. See here, B171 256 is there for first row and as well as for the second row. Here duplicate values are allowed. Second one, unique constraint. Unique constraint designates a column as unique key, means it does not accept duplicates, means no two rows in the table can have the same value for unique key. This unique key constraint accepts null values for that unique key column. When you specify unique key constraint on one or more columns, Oracle implicitly create index on that unique key column. P plus tree index will be created. Let us see the syntax for this unique constraint. Create table, table name, column 1 and data type, and we need to specify this unique keyword. This is the column level syntax, means we are specifying this unique constraint on this column while we are defining this column. For this unique constraint, we can use table level syntax also. In this table level syntax, first we will create table with all the columns. After that, you will define this unique constraint. Unique on column 1 and column 2. This is the table level syntax. This is the column level syntax. While creating the table, we can add the unique constraint by using these two syntaxes. For existing table also, we can add a new column with unique constraint by using this syntax: alter table, table name, add a new column and its data type and size, and unique constraint. Let us see this unique constraint in Oracle. See here, not null constraint will accept duplicate values for this not null column SID, but unique constraint will not accept this kind of duplicate values on this unique key column. Let us drop that previous table student and again we will create student table with unique key constraint. See here, create table student SID character of 10. We are specifying this column as unique and then name and GPA columns and table created. Let us enter values into this table. Insert into student values B171 256 Raghu 8.9. One row is created. See here, one row is inserted. Let us try to insert another row with different values. But see here, for this SID column, I am entering same value. Previously we entered for student Raghu B171 256. This is the duplicate value. So Oracle is raising this error, unique constraint violated. Means for this unique key column, you need to enter every time different value. Duplicates are not allowed. See here, this is the column level syntax. Let us see the table level syntax for this unique key constraint. Let us drop this table again. In this table level syntax, we need to define all the columns first, then we need to add constraint. After declaration of all columns, I am declaring this unique key constraint. Now we are applying unique key on both the columns SID and name. Table created. Let us insert data into table. one row is inserted into this table. This is also inserted because here if we use table level syntax, record level checking will be applied. Here we declare SID and name as unique. So this combination SID and name B171256 and Raghu, and this combination B171256 Suman. These two are different. If unique key constraint is applied on only this SID, the second row would have been raised error, but here this unique key constraint is applied on SID and name. If we take the combination of these two rows are different. Let us try to insert another row. See here, we are using B171256 and Suman. This SID and name combination is same as second row, so it raised unique key constraint, violated error. So for this combination SID and name, this total value should be unique for each and every row. Third one, check constraint. It specifies rules for values within the column. The entire statement is aborted if any check constraint is violated. Syntax for this check constraint. This check constraint can be expressed as a table level syntax or column level syntax. This is the column level syntax. While defining this column, we can specify this check constraint, create table, table name, column 1, data type and size, check and its condition. Like that for the second column also. You can add this check constraint for the existing tables also on specified column by using this syntax, alter table, table name, add check on. You need to specify column name here with some condition. This third one is for while adding new column, you can specify this check constraint for the existing table. This third one is for add new column with constraint for the existing table, alter table, table name, add. Here we need to specify new column name and its data type and size with this check constraint. Let us see how to add this check constraint in Oracle. Let's see the check constraint in Oracle. Let's see the data within the student table. Student table has these two rows. Let us add check constraint for this student table on this GPA column. Alter table student, add check constraint on this GPA column. GPA should be greater than 0 and GPA should be less than or equal to 10. Table alter means this check constraint will be applied on this GPA column. If we insert value for GPA other than this range of values from 0 to 10, then check constraint violation will be there. It will raise check constraint violation error. Let us see that. Let us try to insert another student record with GPA 12. Now see, Oracle raised check constraint violation error. Even if you insert negative values, insert into student with GPA -2, it will raise the error. But if we enter proper value within that range 0 to 10, like 7.6, then it will be inserted into the table. Now we can check the data within the student table. This new record is inserted into the table. We can even add this check constraint for the existing table while adding new column. Let us see one example for this syntax. Let's see this. We are adding new column age to this student table with check constraint age between 5 and 50. Table alter. If you see the description, it will add one more column for the student table. Age is added. Let us try to insert some data into this table. See here, age is entered as 60 for the student, so it raised check constraint violation error. But if you insert value between 5 to 50, suppose 45, that row will be inserted into table. Now you can check the data within that student table. This new student Ram inserted into this table, age 45. While creation of the table also, you can specify this check constraint. We have seen example for not null constraint. Like that also you can declare check constraint while creation of the table. Let us create another table branch with check constraint. create table branch with columns name and branch ID. Here branch ID value should be 1 to 9. Table created. Let us try to insert the data. Branch name CSE and branch ID 11. But here we have check constraint. Branch ID in between 1 and 9. It raised check constraint violation error. If you give the value between 1 and 9, row will be inserted into the table. See the data, 1 row inserted. Fourth one, primary key constraint. Primary key constraint combines not null constraint and unique constraint in single declaration. Means it prohibits multiple rows from having duplicate values in the same column or combination of columns, and prohibits values from being null. Means it does not allow null values and duplicate values. It uniquely identifies rows in table. A table can have only one primary key. Like unique constraint, whenever we create primary key constraint, Oracle server create index on that column. Syntax for this primary key constraint. While creation of the table, we can specify this primary key for the specific column. This is the column level. Create table, table name, column 1, data type and size, and this constraint primary key. We can even specify this primary key constraint by using table level syntax. Means after definition of all columns, we can specify this primary key constraint. This is more useful when primary key is composite, means which is combination of more than one value. Create table, table name, column 1 and its definition, column 2 definition, primary key combination of this column 1 and column 2. This is the table level syntax. We can even add primary key constraint for the existing table by using this syntax. Alter table, table name, add primary key. We need to specify the column name. Let's see the primary key constraint. We have this table student. Let us add primary key for this existing table. Adding primary key for existing table can be done by using this command. Alter table, table name, add primary key. We need to specify column name. Let's check what are the constraints applied on this table first. We can see the constraints which are already applied on this table by using this command. Select constraint name, constraint type from user underscore constraints where table name equal to student. Let's see, here we have 4 constraints. One is unique constraint and 3 check constraints. While adding constraint to the table, Oracle automatically gives the name for the constraints. If you want, you can use user defined names for the constraints. Here we don't have any primary key constraint on this table student. Let us add now. We can make this SID as primary key by using this alter statement. Alter table student, add primary key. See here, it cannot be added because primary key will not allow duplicate values for this SID column, but here we have same value for 2 rows. That is the reason we are unable to add this primary key. Let us delete 1 row from that table. 1 row deleted. Now we have all unique values for this SID column. Now you can apply this table alter. Now you can check primary key constraint is also added. All the constraints are stored in this user underscore constraints data dictionary. So we are displaying all these constraints from this table. You can add this primary key while creation of the table also. Let us see this one. Let's drop this student table. We'll create it again. Table drop. Let's create student table with 3 columns and SID is the primary key here. Table created. Let's check the constraints on this table. Only one constraint is there, that is the primary key constraint. Primary key will not allow duplicate values and it will not allow null values for that primary key column. Let's check that. Let us insert data into this table. 1 row inserted. If we try to add another row with the same value for the SID column, primary key column, it is saying that unique constraint violated. Here we have only primary key constraint, means which is the combination of unique constraint and null constraint. So it is saying that if we try to enter duplicate value for this primary key column, it raised error message unique constraint violated. If we enter other than this 256, that value will be inserted into this table. If we try to leave that SID blank, primary key column blank, null values are also not allowed, so it will raise the error again. Name GPA cannot insert null into this SID. Primary key will apply this unique constraint and not null constraints. So we need to provide value for the primary key, and that should not be duplicate value. Let us add primary key by using table level syntax. This is useful when you want to make more than one column as primary key, composite primary key. Let us see that one. Let us drop this student table, and again we will create that student table with composite primary key. Table dropped, there is no object. Let us create table again. After defining all the columns, then define the primary key. Here we want composite primary key, so SID and name combination. Here we got error. Table can have only one primary key. Here we declared primary key as SID and name, and also here we specified SID as primary key. So remove the first one. Table created. When we have this composite primary key, while inserting data, combination of this name and SID should have unique value. Inserted. This row will also be inserted because combination of this name and ID is different from this combination name and ID, because here we have another name. Row created. But if we try to insert this 171,256 Suman, this row is same as this row, so this will not be inserted again. Unique constraint violation. Fifth one, foreign key constraint. Foreign key constraint, it is also called as referential integrity constraint, which designates a column as the foreign key and establishes a relationship between foreign key and the specified primary key. This primary key also called as referenced key. Foreign key can also be composite. Table containing the foreign key is called child table. Table containing the referenced key called parent table. If foreign key and referenced key can be on the same table, in that case parent and child tables will be the same. We can define foreign key constraint on single column, either inline or out of line. Inline means column level and out of line means table level syntax. For the single column, you can use this column level syntax or table level syntax, but if you want to specify composite foreign key, you need to use this table level syntax out of line. For one table, only one primary key will be there, but whereas you can have more than one foreign keys for a table. And also a single column can be part of more than one foreign key. These foreign key values are always from the primary key values, or it can be null. Let's see the syntax. Create table, table name, column 1, data type and size. This column and references another table called parent table. In that we need to specify primary key column name. This is the column level syntax. See here, this is the table level syntax. Create table, table name. You need to define all the columns. After completion of defining all columns, we need to define this foreign key of column 1 and column 2. References, parent table name, and we need to specify primary key columns here. Foreign key adding while creation of the table, you can use this two syntax. Even we can add foreign key for the existing table also. For that we need to use this syntax: alter table, table name, add foreign key and foreign key column, references, parent table name. See here, if you identify only parent table and omit the column name, then foreign key automatically references the primary key of the parent table. So here, even if you omit the column name of this parent table, automatically Oracle will take primary key column here, primary key column, or you can specify that primary key column. Both are okay. See here, we have two tables: student, student ID, student name and GPA, and we have another table, branch ID and branch name. If we want to establish relationship between the student and branch, means we want to add branch information of student, then we can add this branch ID for this student table as a foreign key, which is coming from the primary key of this branch. Let us check whether this BID is the primary key for this branch. Let us check constraints on branch table. While checking the constraint, you need to use table name in capital letters. Only check constraint is there. This BID is not the primary key. So let us add primary key for that branch table. Table altered. If you check now, primary key is also there. Now we can add that BID as a foreign key in student table. Student table exists with these 3 columns. Now we will add this BID as a foreign key in this student table. It raised error, column type incompatible with the referenced column type. Let us check the description of the table. Here we declared branch ID as number. Table altered. If you see the description of the student table, this BID is added. Now this BID is the foreign key. If you try to insert data into this foreign key, that should come from the primary key of this branch BID. Let's check the data within the branch table. There is no data. Let us insert data into branch table. Branch name CSE and branch number suppose 1. One row is created. If you want to insert data into the student table, we need to supply value for this foreign key column BID, which should be from this primary key of the branch table. If you give value 1, this value foreign key value, this is for BID, which is coming from the primary key value of this branch. So this will be inserted, unique constraint violated. So let us change the different student ID from 59. One row created. If we try to insert one more row with branch ID 2, see here integrity constraint violated, parent key not found, means this 2 is not within the parent table. Here branch is the parent table. If you have this value here, then only this value will be allowed in this child table. If we insert other than primary key values into foreign key, the integrity constraint violation will happen. So that row will not be inserted into database. That is called a restrict operation. Database schema designer can specify alternative actions by using onUpdate or onDelete clause. Before deleting parent table rows referenced by the child table, we need to delete the child table rows first, then we can delete the parent table rows. Because child is pointing to the parent, so we cannot delete parent rows directly. Deletion or updation in parent table, we can use this too. On delete or on update cascade. Cascade will propagate the changes when the parent changes. If parent table rows deleted, all related rows in child table will be deleted when we use on delete or on update cascade. But if you use on delete or on update set null clause, if parent table rows deleted, all related rows in the child table will be set to the null value. Syntax will be like this: alter table, table name, add foreign key, references, parent table name and primary key column, on delete cascade. Or here you can specify set null also. If you use update operation, you can use on update here. We have 2 tables. Suppose student table contain this data, branch table has this data. Here we have 2 branches, CSE, branch ID 1, ECE, branch ID 2. These 2 students, Ravi and Balu, they are from department 1, and Nikhil and Akhil, they are from department 2, ECE. Let us check constraint on this student table. Here we have only primary key constraint. Let us add foreign key constraint with onDelete set null clause. Here we are making this last column BID in student table as foreign key. Table altered. Then you can check the constraints. Now referential integrity constraint also added. If you try to delete the row in this branch table CSE here BID equal to 1, then all the referencing rows here within this child table, this row Ravi and Balu, for this foreign key value BID will be set to null if you use this on delete set null clause. One row deleted from the parent table. You can check the data within that parent table. Only one row is there. CSE branch deleted from this branch table. If we check the student table, this row is not deleted from the table, but this foreign key value BID set to null. Previously it was value 1 and 1 for these two rows. Now these two values are set to null values. Let us drop this constraint C007017. This is the foreign key constraint, and we will create that. We can drop constraint by using alter table student drop constraint. We need to specify constraint name sys C007017 table altered. Let us add foreign key constraint by using onDelete Cascade class table altered. Now this foreign key constraint added by using onDelete Cascade. If you try to drop the columns from the parent table, now we have only one branch ECE. Its branch ID is 2. See here in this child table we have two rows with branch ID 2. These two rows will be deleted from this child table when you delete this branch 2 in the parent table branch. Now check the data in the student table. See here this Nikhil and Akhil, two rows are deleted from the student table because you use this onDelete Cascade. When you drop the parent table row, all the referencing rows in the child table will be deleted if you use onDelete Cascade. If you use set null, child table rows will not be deleted, but foreign key value will be set to null.